Hey guys, welcome to the second episode of this 1973 TBI TR6. TBI stands for throttle body injection, also known as the Patton machine, because it's made by Rick Patton. And in the first episode we explained a little bit how the Patton machine works, all the sensors, all the gadgets that are part of this whole entire system, and we started diagnosing it because there were few things that the owner of the car wants to be addressed. First of all, the engine was running rich, it was dieseling at the end when you turn it off, and it was smelling like gas as well. So what we figured out was that the system somehow was not getting warm enough, or it was getting warm enough, but the sensor probably was not reading the correct temperature here, because this fitting here, this is the temperature sensor, and this fitting here was not warming up. So we thought maybe that the temperature sensor is not reading the correct temperature, and it thinks that the engine is too cold and tells the computer that it needs to do something about it. So the computer makes the idle air control valve bleed some air into the manifold, making the mixture rich so the engine can warm up, just acting like your choke on a carbureted engines. Okay, now here it's probably a good spot to clarify something that I didn't make very clear, and it brought up some questions, very reasonable questions I should say. So how does adding air to the mixture make it more rich? It makes it lean, right? Yeah, that's correct, but in a carbureted engine. Here don't forget that we have a brain called ECU that, based on certain sensors, makes certain changes. So what happens here is the ECU controls the amount of fuel injected through the injectors in the cylinders based on the readings from the MAP sensor. MAP sensor measures the vacuum, right? So when the ECU sees lower vacuum based on the MAP sensor readings, immediately it thinks, okay, the car is under load, so let's inject more fuel, and that's how it makes the mixture rich. So by bleeding air into the manifold through the IAC valve, we don't make the mixture rich directly, we trick the ECU to make the mixture richer based on the vacuum that drops, because adding air through the IAC valve is basically a vacuum leak, right? So that's how, by adding air into the mixture, we make it rich. I hope that makes sense. I'm also thinking that maybe by adding air to the mixture, we make it lean initially, and the O2 sensor senses that as well, because now we have too much oxygen in the exhaust gases. So when the ECU sees too much oxygen, adds fuel and makes it richer. I'm not sure about that, it's just a guess. Here though, we figured out that the actual temperature of the engine is warm enough, and we even went through the troubles to blow through the cooling system here to make sure that this warming tube that's inside the manifold has flow of coolant through it. I think we were able to make it travel properly and warm up properly, but the idle air control valve was still bleeding air into the manifold, and we don't know why. Another problem that we figured was that the two carburetors, or actually now they've been converted to throttle bodies, so we shouldn't call them carburetors anymore, but we figured that the two throttle bodies were not synchronized, meaning that there was different airflow here between the two. So we corrected that, we equalized the airflow, and after that we calibrated the throttle position sensor with a voltmeter, because this whole thing can be hooked up to a computer, which we have here, but the problem is that I didn't have the correct cable to connect it to the port, which is WinALDL port, because the ECU that this system uses is from a GM from the 90s. Many of the GM cars in the 90s used this exact ECU. So that's what controls this system. So we didn't have the proper cable to connect our computer and get correct readings here. So that's why I used the voltmeter to calibrate this throttle position sensor. And I think we did a good job with that, because the engine ran pretty well after that. But the problem was that the idle air control valve was still bleeding air into the manifold even when the engine was warmed up. And we confirmed that by pinching this hose, and once we pinch it, the engine smoothens up and the RPM goes down. When we let go of the clamp here, air starts going in and making the mixture rich again. So that's where we ended the video, and I tried to bring you up to speed quickly here, but I believe that if you haven't watched that video, maybe this video is not going to make much sense. So unless you're really familiar with the Patton machine and the TBI, you should watch that video first before you watch this one, otherwise it's not going to make much sense. But if you're up to speed now, let's continue with diagnosing now, because I have some exciting news. We got the cable. Alright, so this is what I tried using so far. It's a stupid experiment that didn't work. It's a 12-pin ALDL adapter to OBD2 and then OBD2 to USB. I was hoping that by plugging them in together, I was gonna have what I need. It didn't work. It was a waste of time. Anyway, this is what we need, and this is what comes with your system when you buy one from Rick Patton, so there's no point of trying stupidities like me. It was just a waste of time. But today, the owner of the car was able to get in touch with the shop that installed the throttle body injection system in this car, and they had his original cable that came with the kit. So they shipped it to him, he shipped it to me. I already plugged it in. We have an ALDL plugged in there and a USB plugged into my computer. So let's see what we can read now. Alright, this video is obviously a little bit out of sequence. You can see I keep changing clothes. Well, I'm editing the video right now and I realized that I didn't show a lot about the software and how to set it up. So first I'm gonna go ahead and show you everything about the software, and then we're gonna go ahead and start reading sensors and stuff like that. So the first time I plugged in the cable into the USB port of the computer, the Windows found the device automatically, and it gave me a message here that the device was installed properly. So there was no user action needed at all. It happened automatically. It installed it. And then I came to open the WinALDL, and that was the error message that I got. So what this error message means is that WinALDL went to USB 1 on this computer and found that there was nothing plugged in there. Depending on your computer, you might have 1, 2, 3, 5 USB ports, and they all have numbers. The one that I use on my computer happens to be USB 5. So I just said OK here, and this is the software, but we're gonna come back here. First, we're gonna go to configuration, and right here you see COM port. This is the default setting of the WinALDL to go and look at COM1. So this of course gives me an error here. So like I said, mine is in USB 5 and they are not numbered, but I just experimented and I found it by just went 2, it still gave me error 3, error 4, error 5, and it says OK. So now WinALDL sees the cable and eventually the ECU. The other settings that you have to do here are, first of all, the ECM type. So by default, it gives you this ECM types. There are 2 different types, but they have obviously the same settings. So usually it is this one, 1228062, but to make sure, I went under the dash and I took picture of the ECU, and I have this number here on a sticker, so I selected this ECU, which is ECM. ECU is the same thing. Engine control module or engine control unit, but you can see here that there are different ones, and you should find the one that corresponds to your ECU. This one happens to be this one. So once this is set, you have to also come here and change the baud, which honestly I don't know what that is, but it needs to be set to 4800, and that's everything. Now your software is set. So this is the home screen of the software, and it has different tabs on top here. And raw data, you can see all the sensors listed here, but this is the raw data, means voltage or resistance or whatever units the ECU recognizes. So that's a raw data. Flag data, I have no idea what that is. Sensor data is now all the sensors, but here in the first column, it shows you the raw data that we just explained. Then it shows you the conversion. Coolant temperature, for example, again, I don't know what it measures in raw, but it converts to Fahrenheit in this column, and then it converts one more time to Celsius. The TPS sensor reads volts between 0.5 and 3.8 volts, but that converts to percentage of open throttle. So 0.5 volts corresponds to 0% open throttle, and 3.7 volts corresponds to 83% open throttle, for example. So this is your sensor data here. Error codes, BLM, we're going to talk about BLM later. I don't know a lot about the other tabs, so that's the page that I'd like to use. And then the other thing that we can use here is this dash panel, which is great, gives you a quick view of some of the important sensors. So speed, obviously we don't have speed because we have no sensor to sense the speed. RPM, we all know what it is. This is the vacuum, so that's the reading from the map sensor. Throttle position sensor, so here it shows it in percentage, not in volts. And the O2 sensor. Now when we turn the ignition on, we can see the data here. IAC valve that we keep talking about. 40 means 40 steps of the stepper motor that opens and closes the valve. I believe it goes up to 60 or 70, I don't know what is fully open position, but 0 means that it is fully closed. The coolant temperature, as you can see, 202 raw units. That's probably resistance or something that it measures, but that converts to 66 degree Fahrenheit or 19.2 Celsius, because the engine is cold right now. Speed, we said we don't have. Map, 4.9 volts, and that converts to 102 kilopascals of pressure. RPM is obviously RPM. Throttle position sensor, again, here you can see 0.55 volts at fully closed, which corresponds to 0.2% opening of the throttle. Integer O2 varies all the time here, even with the engine not started, I don't know. Knock counter, BLM, reach link counter. So I don't know exactly everything about that, but now we can start the car and we can observe what's going on here. So as you can see here now, the idle air control valve is open, allowing air to bleed inside the manifold because the engine is still cold. The coolant temperature is 97 degrees Fahrenheit. After 160 Fahrenheit, the idle air control valve should start reducing the steps, and eventually, when the engine is fully warmed up, should close. It should go to 0 or a single digit number. The problem so far was that this number here couldn't go more than 140, and we needed to go to 160, so the idle air control valve closed. So let's see. So basically right now the car is in warming up mode, which means similar to the situation when you have the choke food. That's when you make the mixture more rich so it can warm up quickly. But let's see if this is gonna keep going up after 140 or it's gonna stop there. Well, it keeps going, which is good. Before it wasn't doing that. So let's see now at 160 if the IAC is gonna start closing, which it already does actually. It's going down from 40, now it's 37. But let's see if it is gonna fully close or what's gonna happen. You see, as it warms up, the more it warms up, the more the IAC valve closes, and now the RPM also drops because now the mixture is not so rich. . . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So it's idling at about 900 RPM, and I want to drop that a little. And it's still dieseling, so that's the other problem. Alright, so it looks like we fixed the problem. I mean, from the old log files that the other shop was sending to Rick, he could see that the temperature never reached more than 140 degrees Fahrenheit, and that was definitely what was messing up the ECU, forcing it to make the mixture more rich. So somehow, maybe by cleaning up the coolant system yesterday, we were able to make the flow better, but now it just warmed up, and once it warmed up, the IAC valve closed and all that. However, I want to drop the RPM a little bit more, so it is idling at around 900 according to the app, and the gauge actually inside the tachometer shows 1100, so it's not really correct. But I want to drop it a little bit more just by ear. I don't like it, which means that we're gonna have to adjust the throttle position sensor after that, because to drop the RPM, we're gonna have to turn the two screws that limit how far back the throttle goes. And we're gonna turn them counterclockwise, maybe quarter of a turn, and that's gonna reduce it a little bit, but that's also gonna change the position, the zero position of the throttle position sensor. So we're gonna have to adjust it and tell it this is your new zero. So we're gonna do that this time with the app. So let me start it again, and I'm gonna adjust. I'm gonna turn the two screws equal amount. We want to make sure that both screws are turned, not only one. Drop the RPM, but what happens now, our throttle position sensor is off. It thinks that we are -3, so I'm gonna turn off the car and I'm gonna adjust the throttle position sensor again. Okay, so I turned the ignition on so we can read the data, and you see now at idle it shows us -0.7 for the throttle position sensor, and this is at full throttle now. It shows us 81. So it needs to be between 0 and 85, something like that, or 84. Well, now it went to 0.2. Yeah. Okay. So we want to loosen the screws here on the TPS and turn it a little bit as the throttle is fully closed, and we're gonna set the value to be closer to 0 than this. Okay. Now they're loose and I'm starting to play with it. It won't, that's too much. So clockwise makes it lower, counterclockwise makes it higher. Too far. It's very finicky, like you touch it a little bit and it goes a lot. I think now we're good. Now hopefully it's not gonna move as I'm tightening the screws. Okay, so the screws are tight, and now let's see how far up it's gonna go when it's fully open. 83, okay. Okay, so now we're good. So let's start the car again and see if the IAC is gonna close again. already open. Oh, okay. Started going down. Interesting that the battery voltage is 11.6, should be above 13. Now it drives. And now it didn't diesel. I guess the spark plugs were fouled a little bit from running rich before and all that, so I think a good test drive is in order. And of course, as we're test driving it, we're gonna keep the computer plugged in and record some data that we can send to Rick Patton, and he can analyze them and tell us if we need any other tune-up or anything else. So let's go for a test drive. Alright, it's me again from the future. So again, the video is out of sequence here, but I realized that I need to show you how to create a log file before we go and create one, right? So the engine is still cold here, so never mind the readings from the sensors here. But to create a data log, you go to data logger and select here sensor data. That's all you need. And then you simply press start. And then you start the car and you start driving around and it records. So if you click on the BLM right here, map readings versus RPM. So let's start the engine. So you can see here how the green cell moves around based on the RPM and the reading from the map sensor. And when a cell becomes green for a certain amount of time or certain times, the ECU collects all the data from all the sensors and generates a number that puts in that cell. And this number is basically the conclusion of the ECU about the current state of the engine. So if the data from the sensors generates a number higher than 128, the ECU knows or thinks that the mixture is too rich and it starts removing fuel. If the number is less than 128, then the ECU thinks that the mixture is lean and it starts adding fuel to the mixture. Now, of course, this is supposed to be done with the car warmed up and in real driving conditions. Here I'm just playing with the RPM, so that's why it's hard to navigate between the cells and the data recorded. It's not really realistic. Alright, so when you come back from your trip, you should just come here on the BLM tab and just say save table, and it creates a file. I'll show you how to find it. And then you come here and you say stop, and that saves another file. Here we save the BLM file and the other one is log file. So now we can exit here and we can exit here, close the app. And now in the folder where you installed WinALDL, which I did install on my desktop, this is where I installed the WinALDL. So if you open this folder, inside you're gonna find the two files. So this is the BLM file and this is the log file. If you open them, you're gonna see some numbers inside, but this is what you send for analysis. The other one, the log file, is this. It shows the readings of all the sensors and everything, but we're not gonna go that deep. So it's important when you're installing the WinALDL to change the installation destination from program files, which is the default, to your document file or your desktop even, or whatever else. Because if you install it in the Windows program files folder, many times that folder is write protected and Windows is not gonna allow WinALDL to save the log files there later. That's why choose your document folder or your desktop or something like that. Alright, so now we can go for a test drive, but as we're going, I want to mention something else that I forgot to do here. It's a good idea to disconnect the battery, or if you know where the fuse is, you can pull out the fuse of the Patton machine for 10 seconds, so you can reset all the sensors and erase all the previous data, so you can start fresh. Still trying to exit my driveway. Power. That's the only thing I'm gonna say. So as you can see here, it starts collecting some data, and at the end we're gonna save the files and we're gonna send them to Rick to analyze. So let me focus on driving here. Alright, so I went for a 15-minute drive one way and I recorded 2 sets of files because on the way there I forgot to disconnect the battery. So on my way back I disconnected the battery first, plugged it in, and I recorded a second set of data log and BLM files. But that was before I knew exactly what I was looking for, like to fill most of the cells on the BLM table. So the files were not super complete. I mean, I could have done much better. So we're gonna do that again, but first I'm gonna wait for a package to arrive from Rick because I sent him the files and he still thinks that there might be a leak around the O-ring of the rear injector, and I could notice that the recorded temperature was still around 170, 160 something, so it is not where we want it to be. We want the temperature that the ECU reads to be the actual temperatures. So Rick is also sending us a rising block for the thermostat, which is a new product. This block goes under the thermostat and it has 2 ports that allow you to plug in the sensor, and even has a second port for something else. So we're gonna wait for these to arrive, we're gonna replace the O-ring and we're gonna install the block, and then we're gonna go for a final test drive and we're gonna create data log file, and hopefully that's gonna be everything because the car already drives well and it is in a much better state than what it was when it came. We also need to do something with the fuel pressure regulator, with the gauge. There is something that is not done properly here, so we're gonna correct that. But all that we're gonna do in another episode. I think this one is already long enough, so I'm gonna finish it here so I can post it midweek for you, and then on the weekend hopefully we're gonna have the car completed and we're gonna have another episode. So that's gonna be everything for today. Thank you for watching, commenting, subscribing, sharing and supporting the channel. Your financial support is really appreciated. It helps me keep the channel going. Without your support, I'm not sure I would be able to spend so much time editing these videos. So I'm really grateful for that. How you can support the channel you can find in the description of the video. There's multiple ways described, or if you go to the main page of the YouTube channel, you can see next to the logo there's links, and these links provide you with different ways to support the channel. So once again, thank you guys, and I'll see you in the next one. Bye.